In this tutorial, we're going to look at factoring. We're going to take a couple of examples, and we're going to look at some more advanced levels of factoring. First one we're going to look at here is we're going to call traditional factoring. And the first clue that we're going to try to factor traditionally is the fact that it has three terms. We have an x to the sixth. We have x cubed, and we have a constant value. So 1, 2, and 3 terms. Now that's just a clue. That doesn't mean it always works this way. But that's the first thing. And the second clue is that I have a sixth power and a third power. So basically we have one that is half of the original. Or the second one is the third power, this is the sixth power. So that's another clue. The first thing we consider is we're going to look at the last term, which is 27. With that value, we need to figure out what two terms are going to multiply to get this value, but are going to add to get this one. Okay, so how we do that, we consider our first term, and we're going to write out some factors, right? And 27 is nice because 27 doesn't have that many factors. 27 can break down into, say, 9 times 3, 1 and 27, and that's about it. And so once we get that value, we have here, we have the 27 and the 1, which I chose 27 and 1 because there is 26. One way we can look to get the middle value is by taking those factors and trying to see which ones add or subtract to get to our middle term, and you can see that clearly. I listed the factors out here, and so we have 1 and 27 and 3 and 9. Which of those two groups give me this value right here? And a lot of the times you may have to do a trial and error. All right, I'm thinking, well, I can do this, I can do that. This one was pretty obvious. We have negative 27 plus 1 to give me negative 26. And you can see how I took this idea and I applied it here. Here's negative 27, negative 27, positive 1, positive 1. The way we did the first two parts was even easier. We said x to the sixth is here and x cubed. So I'm going to break that down into x cubed and x cubed. Remember, if we were to take this and FOIL by multiplying the two first terms together, you'd have to add your exponent. So it'd be 3 plus 3 to give me 6. That would give me x cubed and then negative 27x cubed. So when I combine those values, I get negative 26. And of course, the very last part, negative 27 times positive 1 would give me negative 27. This allows me to confirm that I did the factoring correct. Now, in a simpler version of this, then we would be done. However, we started out with a fairly large degree. We started out with a degree of 6. So I have to continually ask myself, is there anything else that I can do? And when you look at this, we've talked about this in class, when you look at these two problems, you understand that these are two of the patterns that we've talked about. This is the difference of two cubes, because 27 is 3 times 3 times 3, a cubic, and 1 is also a cube, 1 times 1 times 1. And so therefore we have the difference, subtraction, and the sum, which is addition, of both pieces. So what we're going to do is we're going to look at what happens when we have the difference and the sum of cubes, and how we can apply that, how we can take that and look at the next step. So if we really, let me stop here. What we have our two parts. Okay, this shows us that our pattern is there. We were looking at it. We have, in this case, a cubed minus b cubed. So something cubed minus something cubed. That's this piece here. Right, and you can see how we would factor that. That's your formula. And we look over here, we have a cubed plus b cubed. That would be this part. And so when I take these apart, this is what it's going to look like. And so I went ahead and did that for us. I factored those out, and really the only thing I did was I identified what was a and what was b. So in this problem, we know that a is going to be x. A is going to be x in both, in fact. Right? The next part, I say, what's the cube root of the second part? And this part would be cube root of 27 is 3. Cube root of 1 is 1. And so you can see that as we brought this down, I put x over here, I put 3 there, and then we said x squared, just like the term, we're kind of following along this pattern right there. So the first part squared, so that would be x squared. This would be the first part times the second part, so x times 3. You could ignore the signs for this because they're kind of built into the formula. So x times 3 would be just 3x. Then we do the last part squared, so that'd be 3 times 3. That's where I get a 9 from. I do the exact same process with the sum of cubes here by plugging into this second formula over here. And so you can see that pattern there, which is exactly before. One thing that you can be confident in is that when I factor the difference of cubes and the sum of cubes, then it will not continue to factor after that. We do have some squares here, but the sum and difference of cubes does not factor beyond what it is. And so at that point, what we can see is when we finalize that value, my final solution looks just like that, which is simply me taking these two pieces, this part, and writing them all in one piece together. What that does, that allows me to have the opportunity to just put all the factors together, and the order is really not that important. I have all the factors listed, and that's my full factorization. Here's our second part. This is factoring with 4 terms to start with. Here's another technique that is pretty easy, pretty common. What we see here is we have 4 parts. Anytime you have 4 parts, you want to start off by factor by grouping. So we've got a little description, kind of how this works. When you have 4 terms, factor by grouping is a great place to start. And so the way we identify that, or the way we process that, is really we're going to take a look at the first 2 terms. We're going to group those together, and the last 2. What I'm really going to do here is I'm going to look at the greatest common factor between each of the 2 groups. So you have x to the 6th and 2x to the 4th. What's common? Well, be sure to take into account the exponents of the variables as well as the constant values. Those 2 pieces are really what we want to take a good look at, because that's what's going to make my decision. And so what you have, you've got 6 x's, you've got 4. I don't have any constants that are in common. We have just a 1 and a 2. So we're going to factor out an x to the 4th in this part right here. The next part, we look at our values. Well, there's no variables that are going to come into play. So we look at the numbers, negative 16 and negative 32 all share negative 16. So when you factor it, it's going to look just like this. And really what we did was we call that, it's another technique, is what we're looking for, what we call the GCF, or the greatest common factor. I look to see what's common, I factor them out, and this is what you get. Right? And so when I have the greatest common factor in place, what we're allowed to see is basically you get this piece. All right, we have an x to the 4th, we have x squared plus 2 minus 16 times x squared plus 2. At this point you stop. You want to make sure that in this step that what's inside the parentheses is the same. If it's the same, then you've got a continuation that you can factor. You can keep going. You know it's factorable. We're going to factor out this common part. We're going to write it out front, but I want to show you that visually. And so what we can do. And so we're going to take one of these values, and we're going to break it out front. I'll just write that for you right here. So what we're going to do is we're going to take this part, and we're going to write it x squared plus 2 out front. And so those are gone, right? What's left over is we have an x plus x to the 4th power and an x minus 16. So what I'm going to do there is I'm going to bring those 2 parts down here. So x to the 4th minus 16. And I may ask myself, okay, well, am I done? Anytime that you have a degree larger than 1, you have to ask yourself, am I finished? And this is an even power, so I'm asking myself, do I have the difference of squares? In this case, I definitely don't, because it's addition, so there is no such thing as the sum of squares. So this part is done. Let's go over the next part. X to the 4th minus 16. This is the difference of squares. Okay, in this part we have x squared squared. This part we have 4 squared. So that is definitely a difference of squares. So we're going to kind of work that on, and Let me erase these parts here. Let's go ahead and continue on. So we've got that taken care of. So we're going to take those two parts and we're going to kind of look at them right here. So notice that we have the difference of squares. The 16x, what we had here was our ones that we're working on. We knew that we had x to the fourth minus 16. And with that breaks into these two parts. We take the square root of x to the fourth. That's x squared. The square root of 16 would be 4 and 4. Because it's the difference of squares, one gets a plus, one gets a minus. I do it again. I ask myself, well, okay, and you notice that we in our notes right here, this is what the difference of squares looks like, and this is what it factors into. This occurs twice, once with the fourth power and once with the second power, and here's the second powered one. So we have x squared minus 4. So that breaks down into these two parts. Okay, every time that we get the sum or difference of squares, it stays. Okay, the sum of squares stays, the difference of squares, go ahead, it factors out just like you see here. And if we look at the final solution, I took every part that we had and broke it down. Remember, this part came from the very beginning. That was from up here. That didn't break down. Then we had x plus 4 squared. That was this part. It didn't break down. But then the last part broke down into these two pieces. And so that was our final solution for the second one. Here's our last example. This one actually is probably the longer of the examples that we're going to look at today. Here again we have 4 terms, and so grouping is going to be our first choice to at least begin to look at this one. And we're going to take that and we're going to group our values just like we did last time. And we're going to try to see if we can factor out something, and then once we get that done, we'll see if we have any difference of cubes or difference of squares or sum of cubes, and see if we need to finish up that using those other techniques. So you can see that here we went ahead and factored it. We said, alright, the first part's going to have an x to the 6th in common. So you see that here. That pulls out of both of those parts. It leaves me with 3 here and just the negative 1 there. Always remember that we want to try to keep the coefficient here positive. So we pull out the negative 1, and that changes all the signs in these two. Now, that makes me consider are these the same? And they are. So that's definitely good. We're going to keep going. I went ahead and rewrote it. I basically just took the inside part, these two, and I wrote it here. And what was left over, which would have been the x to the 6th, the negative 1, it goes here. Alright, so once we get to this part, we're looking at it, we're thinking, alright, well, what's going on? And here is the difference of squares, and here is the difference of cubes. And so that's actually fairly complex. We're going to break that down. So let's do it one at a time. So you can see here we took this apart and we said, well, 6 is 3 plus 3. And so we broke that down, and then 1 would be negative 1 and positive 1. So here again, this is from here, and this is just breaking down this one little section. So we immediately get another difference of cubes and a sum of cubes. So this problem is turning out to be quite lengthy in its state here. So if we take this one, so let's keep up with what we're doing. This one, I went ahead and brought it down, and I factored it out as well. So now my factorization will be this part times this part times this part times this part. And I need to go ahead and I need to rewrite those as well. So we took the first part we're going to do is we're going to take this part, we're going to bring it down, and we're going to write its factorization out. Remember, at this point, everything we have is still factorable except for this difference of cubes. We factored into that. So these two parts, they're done. They're complete because the difference of cubes won't ever factor again. But we've got to go ahead and do this one again and this one again. Or, well, this one for the first time. But notice that we have these two. These are the same. And so what I can do, I can basically, if I know that this one is going to occur twice, I'm going to have 2 of those and 2 of those. So I don't really have to do it twice. I just have to understand and remember that I'm going to have double those answers plus this answer. And if I remember that, I can make this problem go a lot quicker. And so my answer would end up looking a lot like that. So let's go back over this. Those are a little difficult to see. That's the if you look here, this is x squared. It's kind of hard to see that bottom part of the 2. Right? And so let's kind of go back, pull where these came from. So here's x plus 1, and then x squared minus x plus 1. That comes from our x cubed plus 1. That comes from this number, or this particular part here. All right? And then you have, notice you have 2 of these both, because they're both squared. So 2 of those and 2 of those. That would be from here is one, and here is the other. Okay, once we factored the difference of cubes, or the sum of cubes, remember these 3 parts really are what's left over. I don't have to repeat them. That's how I knew that this would occur twice. I went ahead and did it for you once here, and I did it again here. So we have 2 of these, and then 1 of the one in the middle. And that's what you see up front. And this is how you do that. So my suggestion, my encouragement for you is that you make sure to always ask yourself, can I factor any more? Can it go down any further? Do I have the difference of squares? Do I have the sum of squares? All those things are important. Keep that in mind, and I think you'll have a good idea. So let's review one more time. The things that we looked at, you have grouping, you have GCF, the difference of squares, the difference of cubes, and the sum of cubes. So there's a lot of things. You got to keep your mind on it and keep asking, is there anything else I can do?